Here we're just going to discuss some very basic exponent properties. And the first thing you need to really have a good understanding of is the difference between x plus x and x times x. X plus x is 2x. That's just combining like terms. X times x is x squared. It's multiplying where we add the exponents. It's x to the first times x to the first, and so that's x to the second. Below that, 2x to the third plus 5x to the third is 7x to the third. Again, that's just combining like terms. The exponents don't change, but they have to be the same, otherwise you wouldn't even be able to combine them with addition. Multiplication is going to be 10x to the sixth. So we add the exponents, multiply coefficients, add exponents. X to the third times x to the fifth in the top right, that is x to the eighth. We add exponents. But x to the third to the fifth is x to the 15th, and that's a case where you can multiply the exponents. If an exponent's raised by an exponent, you can multiply them. You could also think of it as x to the third times itself 5 times is a total of x to the 15th. When we divide, we subtract exponents. So x to the 6th divided by x to the second is x to the fourth. We subtract them. Just like we add them for multiplication, we subtract them for division. X to the third divided by x to the eighth would be x to the negative fifth. Now we don't like negatives, so instead what we do is we keep it in the bottom 1 over x to the fifth. And here the exponents for x to the fourth divided by x to the fourth would subtract to 0, and we actually know that anything to the 0 power is 1. X to the 0 is 1. 5 to the 0 is 1. Doesn't matter. Anything to the 0 power is 1. And then these are just kind of the rules we were just talking about, that for multiplying a common base, you add the exponents, like in the x to the third times x to the fifth is x to the eighth. But an exponent raised by an exponent, you multiply the exponents, as in x to the third raised to the fifth. And for dividing, we subtract our exponents.